Revision questions for year 13 mathematics, strand 1, complex numbers. Question number 1, simplify. Part A, square root of -1 times 2i. First of all, we need to replace root of -1, and for that you need to remember that I squared is equal to -1. Making I the subject, we get root of -1. So we now know that square root of -1 is same as I. Going back to the question, root of -1 times 2i. In our first step, we have to replace root of -1. So our question now becomes I times 2i, which gives us 2i squared. We need to further simplify this question by replacing I squared with -1. So 2 into -1 gives us -2. Part B, I squared whole thing squared times I to the power 5. First of all, simplify the bracket. I squared whole thing squared gives us I to the power 4 multiplied by I to the power 5, which is further simplified to I to the power 9. In the next step, we have to further break down I to the power 9 in terms of I squared. So I to the power 9 is same as I squared times I squared times I squared times I squared times I. In the next step, we need to replace every I squared with -1. So we have -1 times -1 times -1 times -1 times I. Further simplifying, that gives us I, and that is our final answer. Question number 2. Solve the quadratic equation 2x squared plus 8 is equal to 0 using the quadratic formula. To answer this question, we have to make sure that the equation is in the form ax squared plus bx plus c is equal to 0. So we need to rewrite 2x squared plus 8 in the general form. So 2x squared plus 8 is equal to 0 is same as 2x squared plus 0x plus 8 is equal to 0. Now we need to identify the values of a, b and c. A is equal to 2, b is 0 and c is 8. Next, you write down the quadratic formula, which is x is equal to -b plus minus square root of b squared minus 4ac whole thing divided by 2a. Then we need to replace a, b and c in the quadratic formula. Replacing these values gives us negative of 0 plus minus square root of 0 squared minus 4 into 2 into 8 whole thing divided by 2 into 2. Upon simplifying, we get 0 plus minus square root of -64 whole thing divided by 4. Now we need to rewrite square root of -64. So in the next step, we get 0 plus minus square root of 64 times square root of -1 whole thing divided by 4. And then further simplifying, we need to replace square root of -1 with I. Therefore, we get 0 plus minus square root of 64i whole thing divided by 4. In the next step, you can simplify square root of 64, which gives us 8. And at the same time, we need to separate the fractions, giving the answer in the form a plus bi. So we get 0 upon 4 plus 8i upon 4. And on the other side, we get 0 upon 4 minus 8 upon 4i. Upon simplifying the fractions, we get 0 plus 2i and 0 minus 2i. For the complex number z is equal to root 3 plus 2i, identify part A, the real part of z. The real part of z is the term that is without I. So the real part of z is root 3. Part B, identify the imaginary part of z. Imaginary part means the number sitting in front of I. So in this equation, the imaginary part of z is 2. Part C, identify the conjugate of z. Conjugate of a complex number simply means changing the sign in front of the imaginary number. So in this case, the conjugate of z is root 3 minus 2i. Question number 4. Find the values of x and y such that part A, 2 plus I is equal to x plus y minus 1i. In order to answer this question, we have to use the equality rule. Equality rule means we have to equate the real part of the left hand side to the real part of the right hand side. And we have to equate the imaginary part of the left hand side with the imaginary part on the right hand side. So in our solution, we will have, according to the equation, the real part on the left hand side is 2. So that will be equated to the real part of the right hand side, which is x. And we straight away get the value of x. Now we have to equate the imaginary part from the left hand side with the imaginary part on the right hand side. So the imaginary part on the left hand side is 1, and that is equal to the imaginary part on the right hand side, which is y minus 1. So we end up with an equation 1 is equal to y minus 1. In this equation, we have to make y the subject. So y minus 1, in order to make y the subject, we have to add 1 on both sides, leaving us with y on the right hand side, and on the left hand side we get 2. So the value of y is 2. Question number 4, part B. Find the values of x and y such that 3 plus 4i into x plus yi is equal to 13 plus 10i. Once again, in order to answer this question, we need to use the equality rule. But before we apply the equality rule here, we need to expand the bracket on the left hand side. And we'll be expanding the bracket using the distributive property. 3 times x gives us 3x. 3 times yi gives us 3yi. 4i times x gives us 4xi. 4i times yi gives us 4yi squared, and that is equal to 13 plus 10i. In the next step, we will replace I squared with -1 and we get 3x plus 3yi plus 4xi minus 4y is equal to 13 plus 10i. And then we have to put together the real terms and the imaginary terms. So that gives us 3x minus 4y plus 4x plus 3yi, and that is equal to 13 plus 10i. From there, we'll be equating the real part with the real part on the right hand side. So we get 3x minus 4y is equal to 13, and equating the imaginary parts from both sides, we get 4x plus 3y is equal to 10. Now we have two equations with two variables, which means we have to use simultaneous equations to solve. We will use the elimination method, and for that we need to multiply the first equation by 4 and the second equation by 3. Now simplifying these equations, we get 12x minus 16y is equal to 52. Second equation is 12x plus 9y is equal to 30. In order to eliminate x, we need to subtract the two equations. So 12x minus 12x is equal to 0. 16y minus 9y is negative 25y. 52 minus 30 is equal to 22. Now to make y the subject, we have to divide both sides by negative 25, and that gives us y is equal to negative 22 upon 25. Now moving on, we have to use one of the two original equations to find the value of x. So I will use the first equation. You can use any of the two equations. So using the first equation, in place of y, we have to write down negative 22 upon 25. So the equation is 3x minus 4 into negative 22 upon 25, and that is equal to 13. Simplifying that gives us 3x plus 88 upon 25 is equal to 13. Now to take 88 upon 25 to the right hand side, we have to subtract. So 3x is equal to 13 minus 88 upon 25, and that is simplified to 3x is equal to negative 237 upon 25. Now to make x the subject, we have to divide both sides by 3, and we get x is equal to 79 upon 25. So the final answer is x is equal to 79 upon 25 and y is equal to negative 22 upon 25.